Okay, so this is coming in very late. It's actually an hour and 15 minutes past the due date as I'm doing this. And this is the video for the pathfinding algorithms in Comp 361. This is particularly A star. This is set up as a JavaFX Canvas based demonstration using nodes to represent the cities in British Columbia, and it has a set of boxes that allow for the algorithm to be inputted and the cities, and it's got all the logic for setting up the search algorithms and using them, and that's done. Oh, this is old. This was for right click. What I do now is I just have the boxes on the side, but that was from testing. And let's go to node. So this is what the nodes class is looking like in here. And it's just got some heuristic values. Basically, it's got the G cost, which measures the costs from the start node, and the heuristic cost, and it basically can return those and stuff like that, and returns the F cost used by A star algorithm, and the edge now has a cost added to it, and we have it's called consistent heuristic right here. It just does a calculate distance between nodes, and then it minuses it by 5, so it always underestimates, and then it always makes sure that it's greater than 0. So then the A star algorithm here just basically follows the consistent heuristic all the way over till the goal and colors it all cyan. You can just see it here, and it basically just calculates the cost based off the heuristics to find the goal. And this is the Dijkstra's algorithm right here. It basically just goes through priority queue by getting the lowest cost first, so compares by cost, and then builds up over time. And then we finally have a grass fire here that just uses the breadth first structure and priority queue, and it just queues them all up, and then if they're neighbors, and then assigns them values, so they get assigned the usual grass fire values 0 to, and then 1, and then 2, all the way away from the goal node. And this just gets the value for the start node, and then colors all the things lower than the start node, all the nodes with values lower than the start node, green. So we can just run it here, and this is what it looks like. See, this text box is turned off the right click thing. Here we go, and we do West Vancouver to Langley as a good demonstration for A star. So it'll go through and assign all the heuristic values and finds the correct path there and stuff like that, and doesn't assign heuristic values to these ones because they're out of the way, and then this one doesn't go there because it's too expensive. Same with this one. And I'm just going to close it every time just because they kind of mess with each other sometimes. I had a thing set for them to turn off after 10 seconds, but I should probably have made it so that whenever a new algorithm is run, they get closed. But here we can do a grass fire. Let's go with Burnaby. Grass fire. The big problem with the grass fire I had was coloring all the nodes in. But there's the grass fire. You go further, I guess. Do something like Surrey, this might make it just turn green. Oh, no, perfect. Yeah, so I don't know if you can see that very well in the video, but Grassfire algorithm is working properly, and let's close it and do Dijkstra's. We can do West Vancouver to, let's say, Delta, and let's go Dijkstra and start algorithm. And yeah, you can see it goes out like based on lowest cost, so it probably goes Vancouver first, and then, or North Vancouver first, then Vancouver, then it probably goes to these and this, like anything lower than this right here, essentially. So like this is going to be less than this plus this, so tracks out. And that's all the algorithms all the algorithms done.